and bases. So let me get started. I'm probably going to break this up into 2 videos. All right, so let's talk about what acids and bases are. They've come up a number of times in this class. So today is the day where we tie up the loose ends. So you can see this kind of weird looking drawing here, but you guys understand Lewis dot structures. So let's go one at a time. An acid is a proton donor. Now, typically, and it forms H3O+. So proton is an H+ ion. If you remember back to when we talked about this stuff, hydrogen typically has no neutrons, so it's got a proton and an electron. So if it's an H+, it's lost its electron, so that's a proton. Acids produce H+, but it's really H3O+. So H3O+ and H+, just realize that H+ and H3O+ are synonyms. Technically it's H3O+, but typically we write H+. All right, acids produce H+ in water. So an example, hydrochloric acid plus water makes this ion and chloride ion. This ion is actually called the hydronium ion. Generically, just this is whatever the counter ion is. This is actually called, the chloride is called the conjugate. We'll talk about that later. Right, but generically, this is what's going on. It doesn't matter what A is. But so you can see it really well. I've drawn it in Lewis dot structures down here. So this is HA. These are the unshared pairs on A, like if that was Cl. And then this is water with the unshared pairs. And so what happens in an acid is the H goes over to the water. So the H is going, and it leaves the electrons behind. That's why it's an H+. This pair of electrons moves to here, and this goes to here. And this bond, this unshared pair becomes the bond, which you can see over here. So this unshared pair here is the bond here. Right? This pair of electrons here, this bond, becomes this unshared pair. Right? So that's what we mean by a proton donor. It's literally donating a proton to water. Water is accepting the proton, and we'll get to that later. So that's what acids are, that's what they do, and this is how they do what they do, when they do what they do. Okay, bases, a base is a proton acceptor, okay, and remember H3O+ and H+ are synonyms. Bases produce the hydroxide ion in water. These things are in funny places. So an example of a base, ammonia, is a weak base, right? Ammonia with water, and an H goes to the ammonia. So generically, B for base, the H goes this way. So looking at the same type of drawing, this is B with an unshared pair. Here's water, and the H is going from water to the base. So this unshared pair becomes this bond here. This pair of electrons here becomes an unshared pair. So there's the forming hydroxide and the proton accepting. And of course, water in this case is donating a proton. Okay? So again, this is what they are, this is what they do, and this is how they do what they do when they do what they do. So that's what acids and bases are. Acids are proton donors, bases are proton acceptors. Now, if you looked at the last couple slides, you can see water's kind of weird, so I kind of redrew these here. Water is what's called an amphoteric substance. It's not the only one, right? But you've seen some weird properties of water, right? The solid is less dense than the liquid. It has a very high specific heat. This is an unusual property as well. It's not an acid. Water is not an acid, and water is not a base, but it can act like an acid or a base. So this is the reaction I showed you. This is referred to as a dissociation. This is the acid forming hydronium ion, and you can see the acid is donating a proton, and water is accepting it. So water here is acting like a base. Down here in the reaction of the base, right? The base is accepting a proton, water is donating a proton, so water is acting like an acid. So water can do both. It can act like an acid or a base. It's not an acid or a base, so don't think if someone tells you water is an acid or water is a base, they're incorrect. I gotta let this dog out. Go on. Go ahead. Watch it. All right. Frequently we talk about strong acids and strong bases, weak acids and weak bases. The only difference between strong and weak acids and bases is strong acids and bases, this reaction that I showed you goes to completion. Here I abbreviated, I didn't put the water in. All right, so this reaction goes to completion. So HA becomes H+ and A-. Okay, this reaction goes to completion. There's a whole concept called equilibrium where reactions have a reverse reaction, so the reaction goes both ways. So H+ plus A- will reform the acid. And so there's two reactions happening at the same time. When that takes place, it makes it a weak acid or a weak base. Bottom line is strong acids and bases react completely, weak acids and bases do not. Okay? It's going to come in, it can be important starting on the next slide. All right, so I mentioned briefly that we had the other product is the conjugate. So in the reactions of acids and bases with water, and again I'm being a little lazy here, not putting the water in the acid reaction, acids form H plus and another product. That other product is called the conjugate. Bases form form hydroxide and another product. The other product is the water. And actually BH plus is not the base. BH plus is the conjugate of the base. Okay, that is the conjugate as well. So if you back up 2 slides here, here's the acid, water, here's hydronium ion, the H3O plus, and the conjugate. Here's the base, water, hydroxide, and the conjugate. I'll fix that. That's the conjugate of the base. All right. So if you look back, they always differ by a proton. So the HA and the A minus, going back again right here, right? The acid and its conjugate differ by an H plus. You can almost think of it like math. If I subtract an H and subtract a positive, I would get this, right? Base and its conjugate, differ by a proton, and bases are adding protons. So if I add an H plus to here, I add H plus, I would get this. Okay? So they always differ by a proton. So I want you to try this. These are acids. I have to tell you if it's an acid or a base, but acids are easy because they begin with H. See if you can come up with the conjugates. So this is a time when you can hit pause, on the video. Give yourself a moment, and then I'll click on this and see what the answers are. Remember, acids donate H pluses. So you hit pause, try it on your own. All right, did you try it? Let's see how you did. So all you do is you subtract an H plus. So again, if we subtract H plus, we subtract the H and we subtract a positive. See that? We subtract the H, we subtract a positive. We subtract the H and a positive, and we get this. So these would be the conjugates of these 3 acids. All right, let's try it for bases. Bases accept protons, so you're going to add H plus. Again, I would have to tell you it's a base. All right, so try it on your own. Hit pause. All right, you're back from pause. Did you give it a go? Let's see how you did. All right, so add an H plus. This is the base. We add an H plus. That's the conjugate. This is the base. We add an H plus. There's a conjugate. Typically, we write acids with the H in front, but you can stick the H wherever you want in this class. Okay. Here, right, methylamine. We add a base. We add an H plus. We get NH2, CnH2, NH3, and the plus charge. So don't forget about the charge. All right. So why are conjugates interesting? Well, the conjugate of a strong acid or a strong base, remember, they completely react, is neutral. That's because that reaction is not trying to go backwards. So that's kind of boring. That's the boring thing. So for hydrochloric acid, the conjugate is chloride. It's neither acidic nor basic. For sodium hydroxide, the conjugate is sodium. It is also neither acidic nor basic. Actually, I think I can get this in one kind of long video, so we'll just keep going. All right, so this is the last slide on conjugates. Interestingly, though, the conjugate of a weak acid is a weak base. All right, so for acetic acid, we just did this. Its conjugate would be this. Remember, since it's a weak acid, the reaction that's forming this is also going the other way. So this is donating a proton, and this is going to pick one back up and go the other direction. So this is basic. All right, the conjugate of a weak acid is a weak base. Conjugate of a weak base, ammonia is a weak base. This conjugate, right, is a weak acid. So weak acids and bases and their conjugates are referred to as weak acid-base conjugate pairs or weak acid-weak base pairs. So here, right, that's a weak acid-weak base conjugate pair. Why is that important? It has to do with their acid-base properties. So actually, I am going to stop the video here, and we'll pick up here with the second video, which will be a little shorter.